Unit 7, pages 212 to 213, anti-differentiation by U substitution. So in each of the examples on pages 210 to 211, the g prime of x, or the license to integrate, existed in the integrand of the integral f prime of g of x times g prime of x dx, or g prime of x was attainable by multiplying by a constant, which you saw in the last 4 examples on page 211. The g prime of x does not always exist, and there are times when it is not attainable by multiplication of a constant. So we're going to consider the example below where we have to integrate x times 2x minus 1 to the third power dx. So in this case, our inner function is 2x minus 1, and the derivative of that inner function is 2. If we look at our integral, 2, which is g prime of x, is not a part of the integrand. 2 is also not attainable by multiplying by a constant, right? Because the part that is in the integrand is x. So in order to get this to equal 2, we would have to multiply x by 2 over x. And that'll give us 2. And 2 over x is not a constant. So no, we cannot attain g prime of x by multiplying by a constant. So in this case, we must find the antiderivative by a method called U substitution. There are pretty much 4 steps for U substitution, as long as you're not looking at a definite integral. So first thing we want to do is let U be the inner function g of x. So we're going to set the letter U equal to 2x minus 1. Next thing you want to do is find du and solve the equation for dx. So in this portion, you are basically finding the derivative of both sides of number 1 with respect to their variables. Right, so if I take dd u of u and ddx of 2x minus 1, get 1 du equals 2 dx. Okay, so you do have to identify that this side was the derivative with respect to u, and this side was the derivative with respect to x. Just keep track of both sides. And now I want to solve for dx. So in order to do that, I'm going to divide both sides by 2. So I have 1/2 du is equal to dx. Okay. Step 3, we want to find an expression for x in terms of u. So we know that u is equal to 2x minus 1. So we're going to solve this for x. So we have u plus 1 equals 2x. So u plus 1 over 2 equals x. Okay, now the last step is to rewrite the entire integrand as a polynomial or polynomial type of function in terms of u, and then anti-differentiate. So we started with the antiderivative of x, 2x minus 1 cubed dx. Now we have a value for each piece of this that is only in terms of u. So x, we know from step 3, is just u plus 1 over 2. And we're going to multiply that by 2x minus 1, which we can rewrite now as u cubed. We're going to multiply that by dx, which we now have from step 2 as 1/2 du. Okay, so we're going to rewrite this entire integrand now in polynomial form so that we can anti-differentiate it. So we have the integral of, can pull this 1/2 out of here, u plus 1 times u cubed times 1/2 du. The 1/2s multiplied together gives me 1/4, and that's a constant that I can bring out. So I have 1/4, and then I can distribute the u cubed, so I get u to the 4th plus u cubed du. And now I can take the antiderivative. So I have 1/4, add 1 to the exponent, so u to the 5th, divide by my new exponent, u to the 4th, divide by my new exponent, plus c. And then the last step, simplify this out. So I have 1 over 20 u to the 5th plus 1 over 16 u to the 4th plus some constant times 1 over 4, which will still give me some constant. So I can keep it as c. And then last but very not least, if I want to make sure that my final answer is in terms of x, just plug in for u. So I know that u is 2x minus 1, so everywhere I see u, I'll plug in 2x minus 1. So 1 over 20, 2x minus 1, 5th, is 1 over 16, 2x minus 1 to the 4th, plus c. Okay, and this works with any integration where you have a composite function. We're going to do another practice, and then at the very bottom of this page we have a definite integral that we're going to look at, which is a tad bit different just because of the limits of integration that you have to deal with. So for this problem we have the integral of 2x minus 1 over square root of x plus 4 dx. We're going to rewrite this so that it's the definite integral 2x plus 1 times x plus 4 to the negative 1/2 dx. So u is going to be my inner function. So if we look at this, this is a multiplication of functions, one of which is a composite function. So over here, the x plus 4 to the negative 1/2 is a composite function. So the inner function that we're going to look at is the x plus 4. The derivative of that, if we do this, we have 1 du equals 1 dx. Because on the left side, we differentiated in terms of u. On the right, we differentiated in terms of x. So solving for dx, dx is equal to du. Great. Now we want to find an expression for x in terms of u. So u is equal to x plus 4. So x is equal to u minus 4. Okay, so now that we have all of our parts, let's put them all together. So we started with 2x plus 1, x plus 4 to the negative 1/2 dx. Now, we know that x is equal to u minus 4. So we have definite integral of 2 times u minus 4 plus 1. Right, we just plugged in for x. We know that x plus 4 is u. So this is just u to the negative 1/2. And we know that dx is equal to du. So now we simplify before we integrate. So we'll simplify the 2u minus 4 plus 1 by first distributing the 2 and then adding the 1. So we have 2u minus 8 plus 1 gives us negative 7. 2u minus 7 times u to the negative 1/2 du. And then we distribute the u to the negative 1/2 and we get 2u to the 1/2 minus 7u to the negative 1/2 du. Now we integrate. So we're going to add 1 to our exponent and divide by our new exponent. So we have u to the 3/2 2 over 3/2 minus u to the 1/2 and 7 over 1/2 plus c, which gives us 4/3 u to the 3/2 minus 14u to the 1/2 plus c. And the very last step, plug in for u. So we have 4/3 times x plus 4 to the 3/2 minus 14 times x plus 4 to the 1/2 plus. Okay, so the very last problem that we have is find the value of the definite integral from 0 to 4 of x square root 2x plus 1 dx. Then check your result using a graphing calculator. So first thing we want to do here is identify our inner function for u. So we have a function times a function, and that second function, the square root of 2x plus 1, is the one with an inner function. So u could be equal to 2x plus 1. Now we want to find the derivative of that. So that was step 1. So now the derivative of that will give me 1 du plus 2 equals 2 dx. We want to solve that for dx, so dx will be equal to 1 over 2 du. That's step 2. Now, step 3 is to find an expression for x in terms of u. So we have u equals 2x plus 1. So subtract 1. We have u minus 1 equals 2x. So x is equal to u minus 1 over 2. There's our third step. Now, with definite integrals where we have limits of integration, 0 to 4, these limits of integration are in terms of x, or whatever variable we're starting with, right? So this is saying that x equals 4 and x equals 0. When we rewrite using u substitution, these limits of integration need to be in terms of u. So our new fourth step is to change the limits of integration so that they're in terms of u. So we start with x equals 4 and x equals 0. we want to end with u equals something and u equals something. So what we need to do is plug in these x values into our first step where we identified an equation in terms of u. So we're going to have u equals to times 4 plus 1, and u equals to times 0 plus 1. So we'll have 9 and 1. So now our new upper limit of integration is 9 and our new lower limit is 1. So this was our fourth step that we didn't have to do when we were just finding the antiderivative, but now we do have to do because we're finding a value for the definite integral. So we started this equation with the function from 0 to 4 of x times 2x plus 1 to the 1/2 dx. Now we're changing that function, so that's all in terms of u. So now we have the limits of integration from 1 to 9 of x equaling u minus 1 over 2 times 2x of 1 being u to the 1/2 and dx equaling 1/2 du. So these two 1/2s multiply together, to give us 1/4. Limit of integration from 1 to 9 of u minus 1 times u to the 1/2 du. Distribute the u to the 1/2, we get 1 over 4. Definite integral from 1 to 9 of u to the 3/2 minus u to the 1/2 du. Now we can integrate. When we integrate this, we get 1/4. Add 1 to the exponent, so u to the 5/2 and 1 over 5/2 minus u to the 3/2 and 1 over 3/2 and our limit of integration from 1 to 9. Okay, so now we can apply Fatak. So we have 1/4, 2 over 5 times 9 to the 5/2 minus 2 over 3 times 9 to the 3/2 minus 2/5 times 1 to the 5/2 minus 2/3 times 1 to the 3/2, which gives us 1/4, 2/5 times 9 to the half is 3, so 3 to the 5th minus 2/3, 3 cubed, minus 2/5 minus 2/3. Distribute that negative, and we get 1/4, 2/5 times 3 to the 5th minus 2/3 times 27 minus 2/5 plus 2/3. And that's approximately 19.86. 6, 7. Okay, so in class, we'll actually do a lot more practice of substitution so that you become way more familiar with it. So if you're still a little bit confused, please come in with questions and be prepared to practice a lot.